Okay, how many students? 19. Okay. I'm sharing my screen. Let me know if it is visible or not. Is my screen is visible? My screen is visible. Please respond. Okay.
Yes, ma'am.
Okay. So 22. Shall we start? Okay. So last class we discussed about trust, right? We discussed about trust. So basically, your trust is your. Please let me know when if here it is raining. Okay. So let me know if my screen is not visible at some point. So basically, trusses are common means of transferring loads from their points of application to the support, and they vary in design, but their analysis always follows the same pattern. So you will get different types of trusses, but and the analyze but the analysis will always be follows the same pattern. Okay, you'll see different types of truss. Say this is one bridge truss, this is one roof truss. So these are the different designs of truss, but the analysis will be same. Okay, in this trusses also loads will applied at the joints, and in these trusses also loads will always apply at the joints only. Okay, so these were the different patterns of truss, but the analysis will always be remain same. The load transfer mechanism will be, this is the top roof, loads will applied on these roofs, and from this roof it will transfer to this, like it will be like slab to column. Okay, loads will apply to here, and it will transfer those loads to these columns, and in this way it will go to the downward sections. The tools, what are the tools we will need to analyze a truss? So first of all, you should know the equation of equilibrium, as we have discussed. Summation of fx equals to 0, summation of fy equals to 0, and summation of movements equals to 0. So those were your equations of equilibrium. Then you will need free body diagram. Okay. Then you should know little bit of trigonometric and algebra, like summation, sine theta, cos theta, and the most important is your visualization. You should know, you have to visualize that where the load will applicable, where your how to do the analysis, which point you will select. Okay, so basically 4 points, 4 tools are needed. Number one is equations of equilibrium, free body diagram, trigonometric and algebra, like sine theta, what will the value of sine theta, cos theta, and little bit of visualization. Okay, next, a simple truss analysis which will do in this class does not consider the weight of the member. So we will not it will not depend on the weight of the member which makes up the truss. Whether it is made up of iron, whether it is made up of another material, will not consider the weight of the member. Okay, it analyzes consider that all loadings are made at connections. So whatever be the load will be applied, it will be made at connections. Okay. A simple truss analysis consider that all truss members are two force members. So all the members it will act. Will consider that the members are two force members. Two types of forces will apply to those members. Uh, just give me a second. Am I audible now? Am I audible? Hello.
Yes, ma'am.
Okay. So this means that we can break a truss down into a collection of elements for analysis. So a truss can be break down into small elements for the final analysis. Okay. This is an example of truss. Okay. These black members are these are your members. Okay, these are your members, and these are the loads applied at the joints on those members, and these are your supports. This is pin supports. Here see the small rollers. So this is the roller support, this is the fixed connection, and these are the members of the truss, and the loads are applied. Here it is shown by red color. Okay, the red arrows are the loads applied externally. The dark black lines are the members. So these dark black lines are your members. Each member goes from connection to connection. See, if this member and this member and this member is connected to a connection, this member is this member connected to a connection. So all the member, each member goes from connection to connection. The black lines along the bottom of the truss represent three separate members. So this is one member, this is one member, this is one member, this is one member. So you can analyze this part, this part, this part. So you know don't need to analyze the whole. You can start your analysis from this section, and this section. Okay. The support condition in this example are a pin at the left and a roller at the right. So pin connection is applied at the left.
Ma'am,
Yes.
ma'am, can you
Yes.
explain from the first?
Hello. Yes.
Ma'am, ma'am, can you explain from the first? The cursor is also not moving.
From where the cursor is not moving? Wait.
Ma'am,
From?
the moment you started to explain this diagram. Ma'am, the moment you started to explain this diagram. Yeah.
Okay. Now which diagram is showing you? Trusses. The red arrow are the loads applied externally. Screen is visible. The red arrows are the loads applied externally. Please respond. Now you're getting the diagram. I'm showing trusses. The red arrows are the
Yes, ma'am.
loads. Now it is visible. My cursor is moving. It isn't.
Ma'am, it's visible.
Okay. Red
Yes,
arrow.
ma'am.
Yes, yes, yes. So the red arrows are the loads. These are the loads. Your okay. Let me note. So these red arrows are your loads. Okay, and these black members are your member of the truss. And these truss is supported on two supports. This one is pin support, and this one is roller support. Okay, this one is pin support, this one is roller support. Why roller support? See, there are three roles are given it. So you will understand that this is the roller support, this is the pin support. Okay. Okay. Then to simplify our analysis, we assign each connection point with a letter. Okay. To simplify our analysis, what we do, we assign each connection, like this connection, we assign each connection point with a letter. So see, I have given a name A, B, C, D, G, E. Right?
Ma'am, it stopped.
Yes. What it stopped? Hello?
It came right now.
Okay. Pick.
Ma'am, it came right now.
Okay. Here I have
Ma'am, the screen actually, yeah.
Screen is visible? Screen is visible?
Hello.
Okay. So this is our trust member. See, if goes anything wrong, please go to the recording link of section B. Okay. The same class I've taken. If something, if you don't understand, suppose if something went wrong because of training, so you please go to the recording of section B also. Okay. I have taken their classes. Okay. So this is the member to make to make easy, Fukato, please watch section B, section B recording. Okay, I'm trying, but here because of rain, maybe sometimes it gets stuck. Okay, so this is the trust member. All the connections I have given a name: A, B, C, D, E, G. So why I have named, so that I can during the analysis I can easily recognize these joints. So I've named them A, B, C, D, E, G. Okay. So each of the members can now be labeled using the points of connection. So first we have named those connections A, B, C, D, E, G. Okay, we have named those connections. Now we have to name these members also. This member, this member we have to name. Okay, based on those connections, based on those connections, you have to name this member, this member, this member, every member you have to name based on those connections. Okay, now I have named them as AB, AG, BG, BC. This alphabetical is not dependent. You can name them as like BA also, this GB also. But I have put the alphabetical order. So I have named this member as AB, this member is AG. This every member is given a name. Okay, naming has been done to make our analysis easy. Is this slide is visible? In this trust, we have the following members A, B, B, C, C, D, D, E, C, E, like this. This slide is visible? Please respond. Okay. So next, the order of the letter is not important as I discussed. I choose to put them in the order they appear in the alphabet. Okay. So if you write this member as BA, no issues. If you write this member as GA, no issues. Okay. Just you should you just name. Okay. So order of the letters is not an important thing, but don't represent this by another name. You are giving a connection name AB, but here you are writing CD. That won't, that will be, it will make it may confuse you. So whatever with the connection name, based on that order is does not depend. You have to name the you have to name the member. So let's begin with method of joins. To begin the analysis of the thrust using this method, we start by identify all external forces acting on the thrust. So our first step, remember from the last class, I have shared the lecture 7 also on that day itself. So from the first class, what was our step? You have to first identify all external loads acting on the thrust. So you have to analyze this, what are the external loads acting on this thrust. If we see this thrust, the visible forces are this, and this at B, at C, and D. But there will be three more forces. How? At roller support, there will be one force, and at pin support, there will be two force. So total three, four, five, six. Total six external force are acting on this truss. Clear this part? Method of joints. This is a question is given to you. See, A, B, C, D. Three forces are acting 500, 500, and 200 at B, C, and D. This screen is visible. Whenever I ask, please someone write yes if it is visible, so that I can go move forward. Is the screen is visible? Method of join. This is usually given in the problem. Okay, thank you so much. So, a question is given to us. Okay, loads are given. These are the external loads are given 500, 500, and 200. And I have given the members as like this. So, what we will do, we'll remove supports and replace them with reactions provided by the support. So, these supports are replaced by our reactions. Okay, so we'll replace these supports as reactions. See here, this is the final. So you know we have discussed in earlier classes that roller support will have only one reaction. So the joint was D, so it is dy. I have represented as dy. Pin support has two reactions, one in vertical direction, one in horizontal direction. So I have given them as name AX and AY. So now we have drawn the you can so we have analyzes what are the external forces applying on this truss. Three external forces given to you 500, 500, 200, and three unknown you have dy, ay, ax. So what is the first step? You have to find these unknown reactions. Okay, and why you need to find these reactions to analyze another to analyze these members. Okay, to analyze these numbers, you have to find all the external forces acting on the truss. So three we have, and three we have to find dy, ay, and ax. So distance is also given to you. A to G distance 2 meter, G to E 2 meter, E to D 2 meter. The height is given to you. This height is given to you 2 meters, and this is the free body diagram. Now we might solve for the reactions at the support using method developed previously. That is f of x equals to 0, f of y equals to 0, and summation of movements equals to 0. So this is our free body diagram. Just ignore the initial members. Okay, you don't need the initial members. Just forget the initial members. So this is here. We'll start basically. So method of joints. So this is our final external loads applying on it. The height is 2 meter. This A to G is 2 meter, G to E is 2 meter, E to D is 2 meter. Okay. Now what? Let's use summing forces in the X direction. Then the screen stuck in phase 27. Phase 27. I'm at 35. Some I am at 35. Just wait for 2-3 minutes because I have moved down some slides now. So it got now it is visible. Method of joint stuck here too. Okay. Same. Just wait 2-3 minutes. I'm on the screen where it is showing method of joints, summing forces in the x direction. Now it is visible.
No, ma'am.
Due to rain, my connection got lost. Because of Let me share once again. Okay, let me share once again. I'll stop sharing and I'll share once again. Now it is visible. Method of joints, summing forces in the x direction. Yes, response.
No, ma'am. Ma'am, not visible.
Let me share once again. Give me a minute. Please respond now. Which what you're getting in the screen, please someone send me in the group or personally. Which screen is visible to you? Please someone send me personally.
Ma'am,
Yes, yes, yes. Say
it's visible now.
visible.
It's visible now.
Okay, okay. Math summing
Yeah.
forces in the x
We are on
direction.
page 35.
Huh? Yes, yes. Page 35. Thank you. Okay. So till now what we have discussed will be given a truss. Okay, external load will be given to us. Then from the supports we have to find what are the reactions we need to find. Okay, here it was a roller support, so I have replaced those roller support by a reaction, because roller support gives only one reaction, that is only in vertical direction. So I have removed that by dy. Why dy? Because the joint was d, so dy. Okay, next, A joint is removed by A was pin joint, so it is removed by two reactions, AY and AX. Let me know if it gets so. What we'll do to find the reactions, will sum up all the horizontal forces equals to zero. So we'll add all the horizontal forces equals to zero. So if we see the figure, only horizontal force is AX. Okay, so I have taken this direction as negative and this direction as positive. So AX is in this direction. So minus AX equals to 0. So AX is nothing but equals to 0. Got this point? This point is clear? This point is clear? AX equals to 0?
Ma'am, ma'am, once again, please.
Huh? Yes? Please type in the chat box. Sometimes
Once again.
once again.
Once
Okay.
again.
Okay. So, what was our first step? When you get the truss, what you do? You replace those support reactions. Here it was given as pin support. Here it was given you roller support. And you know, roller support gives one reactions, and pin support gives you two reactions, right? So you have replaced that roller section by a one reaction, which is dy, and roll pin support as AY and AX. One will be in vertical, one will be horizontal. Now, after getting all the reaction supports and reactions, what you'll do, you'll find out summing forces in the x direction. That is summation of fx equals to 0. That is all the forces in horizontal direction, sum of that will be equals to 0. So if you see the diagram, how many horizontal forces? Only one, right? Only AX is the horizontal direction, rest are in vertical direction, and I have considered this direction as negative. Okay, this direction as negative and this direction as positive. So what is the direction of AX? It is in negative direction, so minus AX equals to 0. Okay, minus AX equals to 0, and if you take it to the this direction, so it will be AX equals to 0. Or you can do that, you can multiply minus in both directions, so it will, cursor is not moving. Wait. I went to my terrace, but now it's raining. I cannot go. Let me do one thing. Let me share my screen once again. Hope this time it will. Have you seen a green cursor? Have you seen a green cursor out of? Ma'am, just go ahead. We'll manage. How will you manage if I don't see you? How will you manage? Here, you cannot manage. Here, the cursor should move, otherwise you won't understand. My green cursor is moving. See, I have drawn three green lines. Green dot, green. Let me share once again. Let me share once again. Now, screen is visible. Now the screen is visible. Not only. Yes, ma'am. Okay. Now let me know. I have drawn three green lines. Visible? I have drawn three green lines. Three arrow. Okay. See, just okay. Screen is visible, right? So just understand. Just listen to me, okay? See, I'll try to understand in that way. See, all the forces are in vertical direction, right? AY. If you see AY 500, 500, and 200, and DY, it is in vertical direction, right? And what we are doing, we have to do summation of all the horizontal direction. So if you see the diagram carefully, which one is in horizontal direction? Only AXY, right? So AXY, I have taken that direction as negative, or just forget about that. Just take AX equals to 0. Forget about the negative direction for the time being, okay? So all the summation of horizontal forces will be equals to 0. So we have only AX, so AX equals to 0. Now this part is clear. Forget about the cursor, this part is clear. Are you able to visualize? Please respond. Have you understood how AX equals to 0?
Yes, ma'am.
Okay, fine. All of you?
Yes, ma'am.
Okay, okay. So here we have done one part ax fx summation of fx equals to 0. So our ax equals to 0. Next, let's move to the next slide, which is method of join summing moments about d. Okay. For this, you should know my cursor should visible. Okay. So for this what is the how you find the moment? Moment is nothing but force into force into displacement. How you find the moment? Moment is your force into displacement. You know this formula? Moment is nothing but force into displacement. So summing moments about d point. So what we are doing? We are finding moments about d point. So assume this as a beam. Assume this as a beam dy. A beam is given to you. Two reactions is given to you. Forget about the AX. AX equals to 0. So we will not consider this port. Just consider AY. So this is AY. Now cursor is moving. Cursor is moving. Or I have drawn a beam. I have drawn a beam. It is visible.
No, ma'am.
No. Okay, just the screen is visible, right?
Yes, ma'am.
Okay. Just understand. Just understand. If you don't understand, then we'll do something. So just understand that this A to D is a beam. Okay. You have two reactions. At A you have reactions AY, and at D you have reactions DY. And five, three forces are acting on it. Like 200. Remove the 200. 200. Just as movement is nothing but force into distance. Okay. How you find the movement about a point? You need to find the force and the distance. So if you want to find the movement about D, so one force will be AY, right? AY into how much will be the distance? This 2, 2 and 2. Distance between A to D is how much? 2 plus 2 plus 2 is 6. So this is your 6 meter. Okay? And which force? AY. plus, see this will go in anti-clockwise. This will move in anti-clockwise. I have given minus sign. Plus this 500 is distance from D. How much? 2 plus 2, 4 meter. So 500 is the force. 4 meter is the distance. So force into distance. Plus 500. This second 500 is at a distance of 2 meter from the D. So force is the 500. Distance is the 2 meter. So force into distance equals to 0. 200, this 200 force will not have any distance, so it will become 0. So we have 3 force and 3 distance. AY 6 meter, AY into 6 meter plus 500 into 4 meter plus 500 into 2 meter equals to 0. Clear this part? Moment about D point is clear?
Yes, ma'am.
Okay. So all the values are given. What will you get? AY. So AY we got 500. Okay. So we A is AX equal to 0, AY equals to 500 we have got. Next we have dy. So how will you find dy? Summing forces in the y direction. I'm in 37 phase. Okay, I'm in the 37 phase. So how will we have found out AX, AY? Next we'll find out dy. So what we left with? We left with summing forces in the y directions equals to 0. So we'll take all the forces in y direction. That is, can you please once again? Okay. Okay. I'll explain one. Moment about D, na? I'll explain once again. I'll annoting. Okay. I'll annoting. If it is visible, then fine. Then please understand. If you don't understand, please go through the recording link of section B. Okay. So, okay, we have to find movement about D. See, we have found AX equals to 0. Next, we have to find AY. So, what we are doing? We are finding movement about D point. Okay, we are finding movement about D point. And how to find movement? Movement has formula force into displacement. Okay, force into displacement. If you multiply force into displacement, you will get a value of movement. So we are finding movement about D point. So let's start with the force AY. So AY is the force, and what is the distance of AY from the D? See, it is below written here 2 meter, 2 meter, 2 meter. So AY is at a distance of 6 meter from D. So your force will be AY and distance will be 6 meter. See here, 6 meter is the distance, force is the AY. They have given negative sign. See, AY is in another direction from 500. So if you take AY, one direction you have to just understand that one direction you have to take negative, and another direction you have to take positive. Now it's up to you what direction you are taking positive and what direction you are taking negative. Okay, but throughout the questions, if you are taking upward as negative, you have to take upward as negative. Throughout the question, if you are taking downward as negative, you have to take that. So there is a sequence. Okay. So I have taken this counter. Means anti-clockwise is negative. That's why I have put here negative. Okay. So hope this part is clear. AY into 6 meter plus. See, the direction changes. Direction of force changes in this direction. So I have taken as positive. Now this force, this first 500, which is at B, is how much distance from D? 2 plus 2. Assume that this, see, you have one member here, right? If you remember from the other structures. So this 500 is acting on actually at this point, at G point. Okay. B, the force at B is actually acting at G. Assume that like that. Okay. So this 500 is at distance of 2 plus 2, that is 4 meter from D. That is, I'm saying that the first 500 Newton is at a distance of 4 meter from D. So second C, distance is 4 meter, force is 500. Okay. Then let's move to the again the same direction. So again positive signs. So we have force 500. Now this 500 which is at C, assume that it is acting at E, and it is at distance of 2 meter from D. So force is 500 and distance is your 2 meters. Next, if you see 200, you have the force, but you don't have distance, which is 0. So it is ultimately becomes 0. So we're left with three numbers only. 6 meter into AY, 4 meter into 500, 2 meter into 500 equals to 0. That is summation of all the movements at D equals to 0. So you have all the values, you just don't know AY. If you solve this, you will get AY equals to 500. Clear? 41 roll number. Now clear? Please respond. Then I'll move.
Yes, ma'am.
Okay.
Now
Thank you.
clear?
Yes,
Please
ma'am.
respond. Then I'll move. Okay. Thank you.
So next we have found out ax, ay. Then we'll find out dy. So what we left? We have used all the two equilibrium equations. That is summation of fx equals to 0, summation of movement at point equals to 0. Now we left with summation of fy equals to 0. So we'll see summation of all the forces in vertical direction as 0. So what are the vertical forces we have? We have ay. So ay I have taken upward direction as positive. So ay minus 500 is in downward direction, that's why minus 500. Again 500 is in downward direction, minus 500. Again 200 is in downward direction, minus 200. Plus dy is in upward direction, so plus dy equals to 0. So from earlier equations, we have got ay value, right, which is 500. So I have put all the values. We don't know dy, so I found out dy after solving that. Dy is 700. This part is clear. How dy is 700? It is clear. See, we could not have found out a ma'am screen is stuck at m equals to 0. Okay, let's wait then. Just listen to me. See, after when we found out ax equals to 0, we could not take summation of all the vertical forces equals to 0 because we don't know dy. That's why we have found out first dy, then we have come to find out the ay part. Okay, just get it. What we have done, we have found out first ax, right? Then we move to find out the dy because we need to find ay. So if you don't know dy, if you don't know ay, how will you find the dy, right? So we have to find the ay, we cannot take vertical forces because we'll need dy. That's why we have to find the ay, we have taken moment about d. My screen my screen is at 37. Is it visible? Coming forces in the y direction. Please respond. My screen is at 37. It is still at 36. In the next class, I'll I need to shift my. Let me share one second, okay? Now it is at 37. Now it is at 37. I am at 37. My screen is at 37. Okay. So see, in the 37, see, we have found out, we have taken the summation of fx equals to 0. We have taken summation of summation of movements about 0. Now we left with summation of vertical forces equals to 0. So if you see the figure, what are the vertical forces? Ay, dy, 500, 500 and 200. See the directions. Ay and dy are in the same direction and 500, 500 and 200 are in the downward direction. So what I'm taking upward direction as positive. So ay. So we'll start from one side. Ay, then minus 500, again minus 500 because it is in downward direction. Again minus 200 plus dy equals to 0. And AY we have found out from the earlier section that AY is 500. So if you solve this, you will get dy equals to 700 Newton. This part is clear? Please respond. This part is clear?
Yes, ma'am.
Yes, ma'am.
Okay. Now I am at 38 slide, 38 phase. That I have drawn, redrawing our system with the known reactions we have. So we 500, 500, 200 was given to us. Now what we have done, we have found out the AX, AY and DY. AX is 0, we know. So we have left it out, and your AY is 500. I have shown the red at A point AY as 500 with red line, and DY at D point as 700 with red line. Clear this part? This figure is clear? Figure at 38 is clear?
Yes, ma'am.
Okay. So next, now for the problem that we had done earlier, we would be finished. Okay, so this is our problem, we'll finish it. In a truss analysis, we want to know what forces is being carried in each of the members. So basically why we are doing all these reactions, all our aim is to find what will be the force, means the members like this AB member, BC member, CE member, how much force is being carried by these members. Okay, so that our structure does not fail. Suppose I'm loading a structure 1000 Newton, so all the members are balanced out or not, all the members are carrying those loads or not. Okay, so that is one objective of this work. I am on the phase of 41. Okay, I am in 41 slide. So each member of the truss can be in one of three conditions. Your the whole member will be in three conditions. Number one is compression. Either the member will be in compression. That means it will be pushing on each end where it is connected. Okay. We are having problems connecting to the network. Some error. Now it is clear. Hello, hello. My voice is clear now. So your member will be in compression or in tension. Compression means it will compress. Suppose suppose you have one member. My voice is clear. Please respond. Now it is clear. Hello. So many students. No one replies. 32 students. Please respond. My voice is clear. Hello.